We're here at gotomath.com. Man, I fell asleep. We're down here at 8.1. Find the area bounded by the curve in the x-axis. Whoa, this looks like trigonometry. Look at that beautiful curve. So this is the graph here to sine x, and I don't have a whole lot of trig right now, but probably be adding it in the future. More trig stuff. Anyway, let's go ahead and write that down. Let's get that written down. We got the integral from pi thirds, so you got to remember the unit circle. 3 pi halves of sine x dx. So you're going to have to remember the unit circle, and what I mean by that, like what's the sine of 3 pi halves or something like that. Okay, so as you can see here, this is not quite 1. This is a little more than 1, it looks like. Shaded from pi thirds all the way to 3 pi halves. Now, remember that the shaded region, if it's underneath the x-axis, we're going to end up getting a negative value, right? So that means that we're going to need to break this thing up, and that is find this area first and then find this area. Okay, now remember this area, remember when we take the integral going from whatever this is supposed to be up to 3 pi halves, this is going to end up being a negative number, right? So we got to multiply by negative, take the absolute value, whatever you want to do to make this positive. Okay, so that's kind of the trick there when we're finding area. All right, so let's go ahead and, did I write this down? Yeah, let's go ahead, we'll find this area first. Now here's the question, where is this graph crossing the x-axis? And that is, so if this is sine is 0 at what? At 0, and sine is also 0 at pi. So this must be pi right here. 3.14, 1, 2, 3, and that looks like about 0.14 right there, as you can see here, right? Kind of makes sense. So we're going to be going from pi thirds to pi, and then we'll be going from pi to 3 pi halves, taking the integral. All right, so we needed a picture to look at on that. Okay, so we're going, so I'm going to just go ahead and write the problem down here. Pi thirds and 3 pi halves. Now, you know, if we took the integral of this guy, we wouldn't be getting the area. Right, so we want to calculate the area, so we actually we have to break this thing up and then do something to it. So that's something you got to kind of keep in mind there. Okay, when we're calculating area, it's important. So we're going from pi thirds to, what did I say, pi of sine x dx. So this is not going to be equal to what we're doing here. I guess I need to keep that in mind. Right. And then, okay, you know what? Let's just go ahead and do this. So then we're going from pi to, what did I say, 3 pi halves? 3 pi halves. Now, this part is the negative, right? The negative. So, okay. So this is actually equal to, let's write this out here, dx. This is actually equal to our original, but since we're finding area, I'm going to actually erase that and make this a minus sign. I know you're like going, whoa, what the heck? Well, because remember, this right here is going to end up being a negative number, and then you have a negative, so that'll make it positive. Right? Does it make sense? I hope so. Well, do we remember what the integral of sine x is? Now remember, the derivative of sine x is cosine x, but when we do the integral, it's negative. It's a negative. Cosine x, and we're going from pi thirds to pi. Okay, we're going from pi thirds to pi. And then we have minus, once again, but sine is negative cosine, but then that's going to make that a positive. You're like, man, all these negatives and positives and crazy stuff. Going to end up making that a positive. Cosine x, and we're going from pi to 3 pi halves, going from pi to 3 pi halves. Okay? Okay. Now, let's look at this one here. So if I plug pi in, what's cosine of pi? Let's come up here and look at the unit circle. It helps. So remember, cosine is your x-coordinate. Okay, remember cosine's x and sine is y? Well, if we're here and we're back here at pi, and it's the unit circle, this is right radius of 1, then this is negative 1. Well, cosine of pi is negative 1, right? And so I'm just going to go ahead and write negative 1 here. Okay? And then we do minus, and then of course we got this negative sign out here. It's kind of, you know what, let's do this. Let's just keep the negative outside and we'll deal with it later. So we have negative 1 minus, and then we plug in pi thirds, and cosine of pi thirds. Now, cosine of pi thirds, now pi thirds is 60 degrees. So we'll say that's 60 degrees right there. Pi thirds, that's 60, right? Okay. We'll do something like that. I don't, anyway, that's, it should be more like here, I guess. So there's some numbers you need to remember here. First off, there's half, right? Let's see, half, square root of 2 over 2, and square root of 3 over 2. Okay, well the square root of 3 over 2 is greater than half. All right. I think, I don't know, 0.86 or something. This is 0.5. I can't remember, but I do know that square root of 3 over 2 is bigger than a half. Now, if we're talking about the x-coordinate here, cosine, you can see that this is the shorter side and this is the longer side. So the shorter side has to be a half, and the longer side must be the square root of 3 over 2. So these are really the three main ones, and this one right here is 45 degrees, associated with pi fourths of 45 degrees, okay? And this associated with pi thirds, obviously, for cosine in this particular case. Oh, no, I'm sorry, pi thirds. What am I talking about? This one right here. Okay, cosine of pi thirds, which is 60 degrees, is going to be the shorter side. This is the side we're interested in right here. So this is going to be a half. So you got to kind of reason that stuff out if you've forgotten it. So cosine of pi thirds is a half. All right. And then we'll just close that up. So we did the upper minus the lower, right? And now we're going to do plus. Of course, we need to distribute that negative across. We'll do that later. Plus, and we're adding it to this guy right here, okay? So we do 3 pi halves. The question is, what is cosine of 3 pi halves? 3 pi halves. Now, what is a pi half? Well, this is a half a pi. So this would be 1, right? 2, 3. And what is cosine? Cosine is your x-coordinate. But we're down here. So cosine, so your x-coordinate is actually what, 0, and your y-coordinate would be 1. And cosine represents the x, so this is going to end up being 0, right? So the upper cosine of 3 pi halves is 0, minus the lower cosine of pi. Well, that would be back over here, and that ends up becoming negative 1. Negative 1. All right. So now let's do the math. So we distribute this negative across. We end up with 1 plus a half, 0, and then plus 1. Right? Does that make sense? Plus 1. So we end up with 2 plus a half, which is 5 halves. 5 halves. The area is 5 halves. Man, that took 10 minutes. The area is 5 halves. I hope the area is 5 halves. Or wait a minute. What did it say? Round to 2 decimal places. Forgot about that. So 5 halves is 2.5, right? 2.5, so we got to round. It says round to 2 decimal places. It should say if needed. I should say that because this is 2.5, so I need to kind of add the if needed in there on 8.1. 8.1 if needed. And it really wasn't needed this time. So there you go. Okay, so we got to review our unit circle. Like I said, there's just 3 values you need to remember. And there you go. So we're here at gotomath.com. Come on by, practice those.